Hey there, welcome back. And this video, I know that I mentioned that it would be a little bit about algorithms, but I thought it would actually be a lot better to explain the different algorithms that you use or that you're going to use for your final project while working on hardware. So before we jump into those algorithms, I thought I would talk about the Arduino board that you should have and sort of how it works. And I would give you guys some standards for when you're coding. How do you keep your code clean, and how do you make it so you can actually debug things really easily? So let's first do the hardware part. So basically what you really care about for this course are going to be digital pins, analog pins, and the power. Okay, you're also going to care about the your breadboard. Okay, the breadboard is how you do all of your connections. And just to sort of be able to just to sort of be able to visualize how the breadboard is connected, I want to pull up a picture. So the breadboard, there's actually two breadboards. One that comes with the actual kit, and another one I think that we ask that you buy. I don't have the small one, unfortunately. I don't think so, at least. Oh, I do. Perfect. But I'm going to use the big one because the big one's really the one you're going to use mostly. The small one's really, it's too small. It's really hard to work with. And when you're doing your final project, you're going to have a lot of cabling going on. So it's just going to be easier to use a bigger breadboard. So I'm just going to show you guys real quick this picture here. Actually, let's just snip it, maybe make it a little bigger on Paint. Okay, maybe it's not the best, maybe it's not the best quality, but what I really want you to take out of this picture is how these are connected. So this one's the power rail, and the power rail, and I have some connections on mine. You kind of just have to ignore them. But the power rail is oh, my voice cracked. The power rail is basically the one with the red line. Let me just make sure that it's showing on my camera. Yeah, so it's the one with the red line. The ground rail is the one with the blue line. And essentially, these ones are connected, if you have your board like this, horizontally. Okay, so they're connected along like this. The whole row is connected, and the ones in the middle, they're connected actually by column. So each of these, like the green one states, is basically just connected because there's a piece of metal right under the grid, and it runs down like this in a column. Okay, and the reason this is important is because when you're wiring, it's important to know where your different pieces go. And I'm gonna make sure that when we're doing the labs, I explain to you how to do the LEDs and the photoresistor and then the servo. But when you're doing your own final project, if you want the ultrasound, for example, the ultrasound like piece of hardware, then you're going to have to first ultrasonic, sorry. The ultrasonic piece of hardware, you're gonna have to look it up by yourself, and you'll have to understand kind of how the breadboard works. So anyways, most of the time they show you the wiring, but it's just useful to know that basically these ones are connected by column and this one's connected sort of horizontally. Yeah, that's the first thing I wanted to to talk about, the breadboard. The second thing, the standard that you really want to follow is when you buy cables, you actually buy a huge pack. And I think the kit that you have to purchase comes with a bunch of them. But when you're working with these, make sure that you always use red to power, so the red cable to power, the black or brown cable to ground stuff, and then I like to use the yellow for data, but you can also use green for data. And the reason this is important is because when you're debugging, it allows you to visualize what's happening. You know that the red has to be going to power. So when you're looking at your circuit, for example, here, I have two red cables that I know that are going to go to power. I have a brown cable that I know is going to be grounded, and I have a yellow cable that, for me, I know that that's going to be where my what's going to be connected to my data pin or my analog pin, which I will explain in a second. And so when you're working with these, just make sure that when you're making your circuit, you color code everything. you have to know, you have to be able to look at it and know what's happening, because it's really hard to debug otherwise. Your problem might be software, it might be hardware, maybe your connection is bad, maybe like there's so many things that could go wrong that minimizing those things makes it easier to work with. So that's the second thing I wanted to talk about. Now let's talk about the actual board. So if I look up an Arduino Uno picture, in your case, you should have it with you. I just want to talk about the pins that you really care about, which are right here. Okay, so 1 through 13, actually 0 as well. Those 0 and 1, I think there's like a special thing that you can do on them. I haven't used them for that reason. I usually try to use anything in the middle. But basically 2 to 13, let's say, just for the sake of making it easier, 2 to 13 are actually digital pins, and these are basically things that can output something between 0 or 5 volts. This is useful because when you're, for example, working with an LED, then that means that you can either output 0, meaning there's no power, or output 5 volts, which will turn the LED on. Then you have GND, which is just for ground, so all of your circuits have to be grounded at some point. And then AREF, which I haven't really used, I haven't really worked with. Then on the bottom side, you're gonna see your analog pins. So analog pins start with the letter A and then a number. Digital pins are just numbers. And analog pins are used a lot of the time for input sensors. So things like the photoresistor, which is just a light sensor, or the ultrasonic sensor, I think is also analog. And basically this one reads you a value between 0 and 1023, okay? And this value 0 to 1023 basically tells you, like, for example, 0 to 1023, if you look at the, if you ever work with a photoresistor, so the light sensor, you'll know that a higher value means that it's brighter versus a lower value means that it's dimmer. So it's just something useful to know. Eventually you can map this to brightness, so 0 can be less bright and then 5 can be the brightest, so you have to kind of shape the input to like 0 to 5 function. And yeah, it's just useful to know between 0 and 1023. And then you also have 3.3 volt power and 5 volt power pin. These are just constantly sort of outputting this. A lot of pieces of hardware use this. I think the servo uses it. I think the photoresistor actually uses it, and I think the ultrasonic sensor uses it as well. There's also the LED screen that uses it, and yeah, it's just useful to know that you have these pins that will power whatever you're using right away. And apart from that, you have the 2 ground pins right there, and that's really all you need to know for this class. The ground, 5 volt, 3 volt, and then you have digital pins and analog pins. Now for coding, I'm going to go over some standards that I like to use. Excuse me, I just ate. So the first thing is serial.begin. This should always be at the top of your setup. This should be always the first thing, because sometimes you like to print stuff even in the setup, and you won't be able to print anything without having it begin. That's the first thing. Second of all, everything like timer wise should, like I'll explain timers next video, but anything that's a timer should always start at the end of your setup. Things that are time critical, start them towards the end of the setup, because this can take anything in between can take a bit of time, and that might offset your results. And then the last thing I want to talk about is how do you access a piece of hardware, and we'll talk about this also in the next videos, but I just want to talk about always using const integers. So for example, if I have a piece of hardware, an LED connected to pin 12, for example, I would call this LED pin, and I would put 12, and this is now gonna be my variable that holds the pin number for which the LED is connected. The reason why it's really useful to have these constant variables at the top is because you might use it in multiple places, and let's say hypothetically you change the LED pin to 10. If you don't have a variable and you have like a bunch of references to 10, now you need to change those references to sorry, let's say in a bunch of places you use 12 and 12 here. If I switch my LED pin to 10, now if I don't have the variable, I need to go manually changing it. Instead, we can just call it LED pin, and whenever I want to change the pin, all I have to do is change it up here. And it's something that is very useful because you might change your digital pins quite a lot, especially if you think it's damaged. So if you want to debug, it's really useful. And this works for analog pins as well, A0, just like that. I know it's a letter. Sometimes people get confused by it. Don't worry about it. Just know that basically this is how you really want to name your pins. Make them a constant, and always remember your constants are all caps and using underscore at the bottom. Finally, for functions, I like to put them towards the end, and basically the way I like to make functions, if you haven't seen functions, by the way, I'd really recommend you either go look them up or wait for that class where they explain functions. I might go over them at some point again, but I'd rather kind of just talk about standards right now. When I like to think about functions, sometimes you don't need to return anything, but I just like to think of like, okay, do I have to do things in the loop? If I do, then I'm going to return it, and my functions are always going to be the first letter, the first word always not capitalized, and then the next ones I just capitalize the first letter. So let's say I want a function that reads the voltage at a certain pin. It would look something like this. Okay, and in 2 videos from now, I think that's when I'm gonna upload this. I'm gonna show you guys why we made this a float and why this is an int. Okay, and why we made something, why we put int pin here. But the general idea is just a function name. I want it to be all lowercase, and then after that the first letter of each word to be uppercase. So if I have read voltage sum, it would look something like this, right? First letter capitalized, same thing here. And then last thing is always have a way to store the state of your hardware. I think it's really useful to have most of the time anyways for things like LEDs and stuff like that you actually need to control. So for example, I'll just give an example here, the LED. Let's say I want to know if something is on or off. Well, I'll make a boolean called, let's say it's a red LED, and boolean is red LED on, and I'm gonna set this to false, okay, because it's always off at first and then you can turn it on. But the idea here is what I want to really sort of show is, first of all, that the name of the variable is the same as we just did with functions. So the first letter is the first word is always lowercase, and then after that each word is the first letter is uppercase, right? But the thing that I really want you to pay attention to is just that you need to be able to store the state of hardware. Sometimes you need to do that because otherwise your software doesn't know if something is on or off. Now that we've kind of gone over these, oh, there's one last thing actually I wanted to talk about, and that is scopes. Okay, scopes are really important in this class. There's a reason why I am making these constants and these variables and setting them there and not here. And the reason is scopes. So what's a scope? A scope, you can think of it, in my opinion, it kind of makes sense as a universe. It's kind of weird, but maybe, or a room or something like that. I'll show it with bubbles, actually. I'll make it a little bit easier with bubbles. So basically, there's like a hierarchy scope, and it kind of goes like this. You kind of keep going down. Oops. You can keep going down and down in scopes, and I'll show you what a scope looks like after. But essentially, what I want you to know is that if you have a variable in this parent scope, I can go down. This variable can be sort of manipulated by the baby scopes, but a variable that's created here cannot go up and then down. It cannot go up at all, actually. You can't go backwards a scope, but you can go forward. So what does this look like? Well, let's use, for example, this boolean. If I wanted to print this boolean out here in the loop, let's say I have a serial dot println is red LED on. Would this work? And I want you to think about it. Obviously, I think I've given enough hints, and I just realized my board is not plugged at all. Sorry. Let me just plug it real quick. There. And there. Oh, wait, actually, perfect. I didn't even have to plug it in. Here it says, was not declared in this scope. So what does that mean? Well, if I were to draw, again, my sort of diagram or hierarchy, this first bubble is the document. So if any variable that I make here, let's say int value equals 10, that is going to be stored here in this bubble. If anything that is later on opened and closed in curly brackets is a new scope. So here I have setup, and here I have loop. And I created this variable as red LED, let's call it red here, in the setup. So back to what I was talking about, red cannot go up and then down. So loop doesn't have access to red. It doesn't know that this variable exists at all. And so I can't, it's out of the scope. If I instead put it here, this will work just fine, right? Because it's in the same scope. It's right here. Okay. Additionally, if I wanted to, let's say, println value, I can do that because value is in the parent scope. So I can actually access this just fine. And if I go to the serial monitor, I just uploaded the code, so it's gonna give it, I'm gonna give it a second. There you go. Value, sorry, it took me a second to realize this is the right thing. Value is 10, right? You can see 0, this is for this, so it doesn't print out true or false, it just prints out 0, 0 is false. And then after that, it prints out 10 from this, okay? Why is scope important? Because I cannot access, because I can actually, so there's two things, sorry, there's two things. One, I can actually, let's say I have value equals 10 here, okay? And I print out value. I can actually modify this plus equals, let's say 10. And it will be modified in the parent scope so that loop will have the new value. Loop will have the updated value. So if you think about it, kind of, value travels to setup, it gets changed. So at first it's 10, it gets printed out, then it's changed to 20, right? Because plus equals 10. And then if you look back, it goes back up and then it gets printed here. So our output should be 10 then 20. If I scroll up enough, you'll see 10. There it is. Somewhere here. There we go. It prints 10 and then it prints 20. So 10 was the first thing, right? Because we printed it here. We added 10 to it and then we get 20. And so the reason why scope is really important is because anything that is used by setup and loop has to be outside here. It has to be. I can't just make it in setup. It has to be up here. So a lot of the times you'll declare your variables, let's say int value, and then you set them in your setup. And this is something that's very common. If I clear output and auto scroll, you're gonna see, give it a second, 10. Right? So very common, declare the variable, initialize it in setup, and then use it in loop. The other thing I just want to say about scopes, just so you guys know, if I open and close my curly brackets, this is a totally new scope, and it's inside setup. So if I make a variable here, test, and it's 20, I cannot print it here. And if I do test and I run this, it's gonna say test is not declared in the scope, as you can see, because what happened was I made a new scope here, so some curly bracket, right? And this one is called test, and it cannot go up and get printed. Okay, so setup does not have access to test. That's another thing I wanted to add. Okay, that's it for this video. I just wanted to explain sort of scopes and standards using colored cables and talking about sort of how the board is wired. And yeah, I just wanted to show you that having standards is important, naming things properly is important, and making sure that you color code everything is really important, and that your variables are very, very obvious is also very important, because then debugging is way simpler. Already debugging Arduino is really, really hard. So yeah, that's it for this video. I'll see you guys in the next video.